All right, welcome. In this video, we're going to discuss how to calculate a visual descent point and a descent rate when you're prepared to brief and fly a non-precision approach. For this example, we're going to use the localizer into Columbus for runway 31 center. Let's look at the approach. At Lessie, we have a 6.1 DME, FAF altitude of 2,000. And for our MDA passing Lessie, we're going to go down to 580 for a minimum descent altitude. There's a height above touchdown of 367. Now the flip gives us a VDP already calculated at 1.7. Now keep in mind, this VDP takes us down to wherever our glide slope indicator is. For runway 31 center, it's about 1,000 feet down. So the 1.7 on an approximate 3-degree glide slope should take us about 1,000 feet down the runway. So for this case, you can go ahead and just use the already calculated and published VDP. Now you may find some non-precision approaches that don't have a VDP already published. So let's go ahead and calculate one as if this approach didn't. So for our VDP, we usually calculate it based off of a 3-degree glide slope, in which case we'll use our height above touchdown over our glide slope. Remember the old Gus wears a hat acronym or saying. So for here we have the height above touchdown of 367 divided by 300. Now you're probably wondering why 300. Well, to give our 3-degree glide slope and the 60-to-1 rule, for a 3-degree glide slope here, for every nautical mile, we want to lose about 100 feet. So there's 1 mile, 2 mile, 3 mile. We want to lose about 100 feet or so. So there's 100, 200, I can't write, there we go, 200 and 300. When you divide it up, to get that glide slope, we get 3 times 100 gives us the 300. And it's pretty much just calculating a ratio. So 367 divided by 300 equals about a 1.2. Now don't make the mistake of thinking my VDP for this particular approach is at a DME of 1.2. Nope, I have to make sure that my VORTAC is giving me appropriate measurements. So from the runway, I already have a distance from the VORTAC of 0.7. So to calculate my VDP distance, I'm going to add 1.2 to 1.7, and I get a DME of 1.9. So my own calculated VDP is 1.9 DME. Now, keep this in mind, our calculated VDP is based off our distance from the threshold. So if you were to leave right at 1.9 and go perfectly on your 3-degree glide slope, you would arrive at the threshold. So you may have to play it out a little bit. In general, if I've got a pre-published VDP, so here we have the 1.7 and I've calculated my own, I like a little bit of a window to try to shoot for to start my descent rate. Because how often right at our DME do we go ahead and start our descent? Nope, we kind of announce to the crew departing the MDA, we get our pitch and power set, and about that time we've already traveled a little bit further, making us right on our glide slope. So in general, that's just my technique of calculating a VDP and using one in relationship to one that's already published. So we've gotten that right here. The 1.9 is our VDP, which takes us to the threshold. Next, we want to calculate our descent rate. Now, for our descent rate, our objective is to get to our MDA prior to our VDP. The MDA is built, you can kind of think of it as like a brick floor. If I'm going to go through my MDA, I'm going to crash. So I need to level off at my MDA and not go below it. Now we're simulating the weather. Here's we go, just over here. The weather's right there and my MDA is right there. I need to get down at a certain descent rate and level off at my MDA prior to my VDP, because if I start my level off at my VDP, let's say I'm going down to my glide slope here, if I start my level off, I'm just going farther and farther away from a safe descent to land. So my objective is to get to my MDA prior to my VDP. So my descent rate should be a little bit more aggressive than as if I were on a 3-degree glide slope from my FAF to my decision altitude. So how do we do this? Well, let's figure out first the distance between our VDP and our FAF. For this scenario, let's just go ahead and use the published one of 1.7. So we have 6.1 minus 1.7, and we get a distance of 4.4. So there's about 4.4 nautical miles in between our VDP and our FAF. Now, how fast are we going in the T1 on an approach? Normally we range for about 108 to 116 knots for an approach, give or take. Let's just use a WAG and call that about 2 nautical miles a minute. All right. Now, how long will it take for us to get through that 4.4 distance? Well, it looks like it'll take us a little over 2 minutes or so. That makes sense, right? For every minute we travel 2 miles. So after 2 total minutes, we'll have 0.4 left over. So a little bit of change. Now, to calculate our descent rate, let's figure out what our distance, or excuse me, what our altitude change is. We're going to go from 2,000 feet down to 580, and we get a total distance of about 1,420 or 1,420 feet altitude difference. Now, to be a little conservative, I'm going to round this up and use about 1,500 feet. Cool. So for every mile I travel, for every minute I travel, how many feet do I need to lose, or how much altitude do I need to lose? Well, if I'm traveling at 2 nautical miles a minute, and I'm losing, and I'm traveling, yep, so I'm going to do 1,500 feet. I'm losing 1,500 feet, and I'm going to divide this by 2. For every minute, I need to lose about 750 feet to get down from my FAF to my VDP. Now, I don't want to use just 750 feet. That may not be aggressive enough to get to our MDA prior to the VDP. So what I want to do is round this up a little bit. I'm going to call it about 900. So I'm going to shoot for about a 900 foot per minute descent rate. Now, if you remember what the 217 says, for a non-precision approach, it recommends using about an 800 to 1,000 feet per minute descent rate. And we see here that our 900 foot per minute lies right there in the middle. So if I were to brief this approach, sir, ma'am, to my instructor, passing Lessie at 6.1, I'm going to leave 2,000 feet down to 580 on about a 900 foot per minute descent rate. This should get me down to my MDA of 580 prior to my VDP of 1.7. And there you have it. Go find another instructor and maybe give them an example and run through some calculations on a different non-precision approach and have them correct you or back you up to see if you made any mistakes.